And we will review these two problems, which hello? As a review of what we were doing on Thursday, this is what's called division of radicals. Sometimes the term used here is to rationalize the denominator of the fraction. Sometimes the term is used divide. But the whole thing is when you are dealing with a fraction that has a radical in the denominator, you want to get rid of that radical. And you look at it in two ways. You first decide, is the denominator one term, a monomial, or is it two terms? Is it a binomial? And obviously this is a binomial because between the two expressions we see a sign. If it's a plus or a minus sign, it makes it a binomial. And when it's a binomial, in order to rationalize the denominator, we have to multiply by what's called the conjugate of the binomial, which means that we're going to multiply by 3 plus radical 2. The conjugate of a binomial is the identical binomial, the same exact two terms, but whatever the sign is in the first parentheses, you do the opposite sign in the second. So this is 3 minus radical 2, and this is 3 plus radical 2. Of course, whatever you're doing to the numerator, you have to do the exact same thing to the, whatever you're doing to the denominator, to the bottom, you multiply the same thing in the numerator. And as I said, I always like to take care of the denominator first, because that's what we're trying to rationalize. And since these are conjugate binomials, when you multiply them, you don't have to do the whole FOIL. You don't have to do all 4 multiplications, first, outer, inner, last, because for sure the outer terms will cancel with the inner terms. So you really only have to do first, which is 3 times 3 or 9. And last, negative square root of 2 times positive square root of 2. Well, a negative times a positive is close, certainly a negative. And when you're multiplying a square root by itself, that just gives you the number that's inside the square root. It removes the radical. So the denominator becomes 9 minus 2, which of course is just 7. And obviously that's a rational denominator. It's just a plain number. It doesn't have any square roots in it. The numerator, we could either leave as 5 parentheses 3 plus radical 2. In other words, just leave it separate in its factored forms. Check if these two numbers can be reduced, but of course 5 and 7 can't be reduced. Alternatively, this is a good answer. An alternatively good answer is when you remove the parentheses and use the distributive property. So you get 5 times 3, which is 15, plus 5 radical 2, the whole thing over 7. Be careful that if you're removing the parentheses, you don't just multiply the 3 by the 5, but the 5 by the radical 2 as well. Both of these are good answers. So that's how you do division by a binomial that has a radical. You literally do what's called rationalizing the denominator by getting rid of the radical. Notice the denominator is now just a plain number, 7. That's a rational number. Okay. The second question had to do with solving a radical equation. And what we said, when we have a radical equation, what we do is we first get the radical by itself. We isolate the radical. So if there's anything outside the radical, we bring it to the other side. So this 4 I'm bringing to the other side. And this gives me my equation radical 2x minus 3 equals 3. Now I take a pause here and look at the number that's on the other side of the radical. That number, if it's just a plain number, has to be, if it has x's in it, then I can't make that judgment. But if it's just a number, that number has to be a positive number, because this, by definition, the square root of a number is always the positive answer. So if this would have turned out to be a -3, for example, I would have stopped right there and said there's no solution. But it's a +3, so I can go further. And I go further by squaring both sides of this equation. Now, the side that has the radical, when I square it, when I multiply it by, square means to multiply by itself. Not taking the square root, I am squaring it. I'm multiplying it by itself. So since it has a radical, when you multiply a radical by another radical of the same thing, all you do is you get the number that's inside the radical. So basically, squaring this just gives us the expression 2x minus 3, whatever is inside that radical. The side that doesn't have a square root in it, that has to actually be squared. You have to do the 3 times 3. Now that is going to give you 9. And now you have a simple equation to solve. And this gives you 6x equals 12. And if you divide both sides by 2, you get x equal to 6. You should really go back and check. Let's just check. 2 times 12 is, 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3. 3 plus 4 is 7. Even if you don't write down the check, you should check radical equations. You might have done everything right and still gotten the wrong answer. You might have gotten an extraneous root. Okay, so that takes us to where we were on. Oh, thank you. Well, that was good. I see a few people had sent me the answer. Excellent. So let's now go on from where we were. At this point, we're finishing up radical equations and we're going on to talk about something else.
Professor?
Yes?
I have a question about the first problem. So after I have the 5 times 2, should I further simplify it?
No, look, it would have been fine for you to leave the answer. If this was an open-ended question, you were just told to give the answer, and you wrote your answer like that, that would be, you wouldn't have to go further than that. That would be fine.
Okay, no problem.
But if it's a multiple choice question, sometimes they'll give the answer in this format and sometimes they'll give it in this format. They're both correct, so I can't tell you which way to write the answer. Both of them are acceptable.
Okay, thank you for listening. Thank you.
Okay, can I erase what's on the board now? Okay, so I want to do one more of these type of problems with the radical equations. And as I said, and then I want to do the last topic in this chapter. And then on Thursday, we'll talk about when we should have, when I'm going to schedule a test on the chapters 5 and 6, because we are now finishing chapter 6. So let's say I gave you something like this. I have the square root of x plus 3 equal, plus 3 equaling x. Again, I have a radical equation, and I want to solve this radical equation. And again, we're going to start with the steps the same way we did before. We're going to get the radical all by itself. We're going to isolate the radical, which means this plus 3 has to be moved to the other side. So I'm minusing 3 from both sides. And we get the square root of x plus 3 on the left side. And on the right side, we get x minus 3. Now, this is a little bit different than what we did before, simply because since we have a variable on the other side, not just a plain number, we can't combine them. They're not like terms. I can just bring it to the other side and get x minus 3. But the procedure is the same. We want to get rid of this radical, so we're going to square both sides. Again, when we square the side that has the radical, when you multiply the square root of x plus 3 by itself, you just get the x plus 3. But on the other side, we actually have to do x minus 3 squared. I'm writing it and I can't do it in my head because this is a binomial squared. And I know it's not just a number squared. I can't just say x squared and 3 squared. I have to actually do FOIL. I have to do x minus 3 times x minus 3, which will give me, using FOIL, x times x, which is x squared, outer, which is negative 3x, inner, which is negative 3x, and negative 3 times negative 3, which is plus 9. So this turns out to be x plus 3 equals x squared minus 6x plus 9. Let me just stop for a second and show you, if you want a shortcut for squaring a binomial, there really is one. I'll do this again a little bit later, but I wanted to show you. It's just following the pattern. If you're squaring a binomial, you take the first term and you square it, x times x, and you get x squared. You take the last term and you square it. Negative 3 times negative 3 is plus 9. But you have to also do one other thing. You have to multiply these two things together, the two terms together. X times negative 3 is negative 3x, and double it. Because if you notice, when we're doing FOIL, we're doing this twice. We're doing the negative 3 times x and then negative 3 times x. You're doing it twice. So just do x times negative 3 is negative 3x. Double it gives you negative 6x to get your middle term. So that's a quick way. I don't know if you obviously you could always do it the FOIL method, but if you're in a rush, you could still do it using this quick method of squaring a binomial. Well, in any case, we have here an equation that is a quadratic equation. The reason I know it's a quadratic equation is because I see an x squared in it. And I know when I have an x squared in my equation, I want to get everything on one side equaling 0 on the other side. And it makes sense to bring everything from the left side to the right side because that's where your x squared is. You want to keep your x squared positive. So that means I'm going to subtract x from both sides. Notice I'm putting things under each other so that they line up. And I'm subtracting the 3 from both sides. So that I end up with 0 now on the left side. And on the right side, I have x squared. Negative 6x and negative x is negative 7x. And 9 minus 3 is plus 6. And I have to solve this quadratic equation. So I'm going to go over here because this takes a little bit more work than we have room for down there. So let me just rewrite it over here. X squared minus 7x plus 6 equaling 0. Remember, we use our AC method to factor. Our AC is 1 times 6, which is 6. And our B is negative 7. So if we think about it, we want two numbers that are going to multiply to 6, but when we combine them, it's going to give us a negative 7. And obviously, since it has to combine to a negative number, both of them have to be negative because my product is positive. And what multiplies to 6 is either 1 and 6 or 2 and 3. And obviously, wanted to combine to negative 7, we're going to use the negative 1 and the negative 7. So we're gonna have x squared minus 1x minus 7x. I'm sorry, minus 6x. So we're using, -1, -6. -6x plus 6. Obviously, the -1x and -6x do give me -7x. So this factors to x times x minus 1. And here I have a -6 as my common factor. And this gives me x, and -6 into +6 gives me -1 as well. So this gives me x minus 1 and x minus 6 equaling to 0. And we set each of these equal to 0, so x minus 1 equals 0 gives me x equal to 1. And x minus 6 equaling 0, which gives me x equals 6. I ended up with two answers, one answer being 1 and one answer being 6. If you notice, this is a lot more work involved when this becomes a binomial that we have to square. It makes it into a much more complex problem. But don't forget, it's a radical equation, so we have to check. So checking with x equals 1. I go back to my original equation, and I get the square root of 1 plus 3. I'm replacing the x with 1, plus 3 equaling 1. Now, 1 plus 3 is 4, so this becomes the square root of 4, which is 2. So I get 2 plus 3 equals 1. And this is obviously wrong because on this side I'm getting 5 and on this side I'm getting 1. This, I did all the right work. It wasn't of the fault of the way I did the work. This is what's called an extraneous root. It's just a root that pops up as a result of doing the squaring, but it's not a right answer and we have to discard it. Now let's try x equal to 6. In that case, we're going to get the square root of 6 plus 3 plus 3 equaling 6. I'm replacing the x with 6. Now 6 plus 3 is 9. So this is the square root of 9, which is 3. So I'm getting 3 plus 3 equals 6. And of course, that is correct. So this is my answer. And that is the only answer. If this was a multiple choice problem, I can guarantee you that they would give you one answer being 1, one answer being 6, one answer being 1 and 6, and then some other answer as a multiple choice. They want to trick you. And if you only went this far and you didn't do the check, you're going to pick the answer that has both 1 and 6 in it. And you would have done all the work correctly until that point, and you would have been perfectly correct in how you solved it, and you still would have gotten the problem wrong. Hint, if you have a problem like this as a multiple choice, it makes sense just to take the answers that they give you and check which ones work. Because in the end, you're going to have to do the check no matter what. So you will have done all this extra work and still be at the point where you have to check. So if you want to save yourself time, just take the answers. If one answer is 1, check it. Does that 1 work? No, throw it out. The next answer is 6. Does that work? Yes, that must be the answer. Or if they give you a choice 1 and 6, don't automatically pick that answer. All right, so this takes us through. Would you want to try one like this on your own? Or should we just go on? You know what? I'm going to give you one like this as a multiple choice. See if you really get it right. Okay, so I'm going to erase this and now give you another problem to try. While you're doing that problem, I will take attendance. Okay, here's the problem I want you to solve. The square root of a plus 10 plus 2 equals a. And here are your choices. This is a multiple choice. Choice 1. -1. Choice 2. Um, 6. Choice 3. -1 and 6. And choice D, no solution. These are your choices that I'm giving you. It's a multiple choice question. Try that while I am taking attendance, and we'll work on it together. Jesus. Jackson. Tiffany.
I'm here.
Okay, good morning. And Jackson, I saw that you're here also. Kayla Brantley. Tashana Caesar. Hi, Tashana. And you're here. I do see that you're here. I saw you before. You would answer the question. Thank you. Dion Carter. Wensley Charlemagne. Tatiana Collins. Hi, how are you? Good morning. Awa Diallo. Good morning. Ashay Douglas. Eliana Estee. Good morning. Emily Gomez. Anastasia Guerra. Zainabu Hamed. Zainabu. Ismail.
Here.
Good morning.
Morning.
Jaden Jackson. Ashiana Jacobs. Good morning. Anijah John. Thomas John. Paul LeBrun.
Thomas John, I'm here.
That was Paul, was that Paul or the Thomas?
Thomas.
Hi, okay. Good
I'm here.
morning.
This is Paul.
Okay, great, you're both here. Good, thank
Yeah.
you.
Good morning.
Good morning. Ashley Moorhead. Angelica.
Here.
Hi, good
Good
morning.
morning.
Tayon, we're just. Good morning. Akeem Phillip. Akeem, you here? Craig Ricketts. Giovanni Rowe. Devin Lee St. Jules. Najay Waddell. Okay. Okay. I'm going to do what I said I told you to do. When you are given one of these questions as a multiple choice, just stick in the answer. Remember, you are required to check this. So I'm just doing the check. Here's my check. What am I checking with? The answers they gave me. So the first thing I'm going to check is with the answer -1. Well, let's see if -1 works. So I'm going to, in place of the A, I'm putting -1, and I'm getting -1 plus 10 inside the radical plus 2 equals -1. And when I do the -1 plus 10, I get 9. So this is the square root of 9 plus 2 equals -1. And the square root of 9 is, of course, 3. 3 plus 2 gives me 5 and not -1. The -1 doesn't work. So now I try my second choice. Actually, that right away tells me that C is not going to work either, because if -1 alone didn't work, it certainly worked with, it's just not an answer. So it's not, one A and C we've eliminated. All we have to now do is check with 6. If 6 works, that's the answer. If 6 doesn't work, we have to take choice D. Notice it wasn't a lot of work to check because it's just checking these two numbers. So checking with 6, I'm going to do the square root of 6 plus 10 plus 2 equals 6. And the 6 plus 2, the 6 plus 10 gives me 16. So this is the square root of 16, which is 4. And 4 plus 2 equals 6 is correct. So this is my correct answer. My answer to this was choice B. Notice by just doing the check, I made the problem so much quicker to do. Of course, you can only do this when you have a multiple choice question. But when you do, make life easy for yourself. Don't forget, you are required to check. So if you have to check, just do the check. Okay, and I see a bunch of people did get B as the answer. Great. Okay, so let's now go on to the last topic in this chapter. which is called complex numbers. And what we're going to be talking about is extending our number system that we use on a regular basis to be able to include a situation in which we're trying to take the square root of a negative number. If you recall, if I gave you something like the square root of negative 25, I said we can't do that. It's impossible to do in the real numbers. Why? Because if you take the square root of, if you thought your answer should be 5, obviously that won't work, because 5 times 5 will give you positive 25 and not negative 25. And negative 5 doesn't work as well, because negative 5 times negative 5 is also positive 25. It's impossible to multiply a number by itself and get a negative number. So what we do is, for certain discussions, this isn't regularly used, but it is used sometimes, we introduce a new number. We're introducing one new number, and that one new number will enable us to take care of the situation. What is that number? Well, I can't call it 1, 2, 3, 4, 5. It's not one of those numbers. It's something new. So we have to give it a new symbol. We're going to call it I. Now notice how I make my I. I don't make my I like this. And you know why I'm not making that I like that, because if I don't make that dot big enough, you're going to think it's a 1. So in order to avoid that, I will always use a script I for this new number. Either this, or you could just actually do it as a script I like to do this little italicized I. What is this I new number equal to? We're taking it to be the square root of negative 1. Now, you know, in the real number system, you can't do that. But this is a new number system. You can call this, it's called, sometimes called the imaginary number system. Not that it's a figment of an imagination. Mathematicians worked on this. They didn't imagine it, but because they had called the other number system the real number system, well, if this is not part of the real number system, so it must be something that's not real, let's call it imaginary. And that's how the name came about. It actually has a lot of uses in, let's say, electrical engineering. It's not something that is just a figment of imagination. It really has major applications. But when you're just doing regular going to the grocery shopping type of work, you're not going to ever use this type of number. Well, how does that take care of the problem of the square root of negative 25? Well, we know how to simplify radicals. Remember, when you want to simplify a radical, you break it up into two numbers that multiply to what's inside the radical. When you have a negative in the radical, you can break this up into 25 times negative 1. Now, what happens in that case is the square root of 25 becomes 5, and the square root of negative 1 is this new number that's I. In other words, I never work with the square root of negative 1. I immediately replace it with I, and the square root of negative 25 is 5i. So we're going to learn how to work with these numbers that are imaginary numbers, and we'll even have numbers that are a combination of real numbers and imaginary numbers. Those are what we call complex numbers. So complex numbers are all the numbers that we've ever talked about all the real numbers together with all the net imaginary numbers combined. How do we work with these things? Well, first of all, let's just see how we simplify. So what if I gave you this problem? I want to do the square root of -25 plus the square root of 36 plus the square root of -81. I want to combine these radicals. And of course, they're not like radicals. They're not the same number inside the radicals. So the first thing we have to do is simplify each radical. Don't forget, you're never going to work with the square root with a negative inside it. As soon as you see a negative inside your square root, you have to change it to an I number. Just like we did before, this became the square root of 25 and the square root of -1, which is 5i. The next number I see is the square root of 36. Well, that's no big deal. That's a regular square root. That's just 6. No y there because there's no negative inside the radical. The last thing I see is the square root of -81, which I can again break up into the square root of 81 or square root of -1. Again, you always want to have a positive square root with a square root of -1. So that the square root of 81 is 9, and the square root of -1 is my I. So anytime I had a negative inside the radical, it translated to a number with an I. If there's no negative inside my radical, it becomes a regular number. This had a negative, so that became an I. And we just find the regular rules of arithmetic, where we first look for all the real numbers, and there's only 6. And then we look for all the imaginary numbers, all the I numbers, and there's a 5i and a 9i. They're like terms. These are just regular, like 5x and 9x. That gives us 14i. And I can't simplify this anymore. My final answer is 6 plus 14i. And this is what's called a complex number, because if you notice, this is one number that has both a real part, the 6, and an imaginary part, the 14i. This is sometimes called a number in the A plus BI form. My A in this case is 6. My BI is the 14i. This is a complex number. There's not much to know about this. It's not hard to work with, because all you have to do is all the things that you know how to do in regular algebra. Only remember that when you have the square root of a negative number and you want to convert it, you have to write it with an I. Now, before I give you any to try on your own, I want to do one more thing. I want to talk about multiplying. This happened to be, we were combining. Let's talk about multiplying imaginary numbers, because that's a really interesting thing. Suppose I wanted to multiply the square root of -9 times the square root of -16. No, let me do something else. Let's say I wanted to multiply the square root of -9 times the square root of -9. What if I wanted to multiply a radical by itself? Now, you might do it in two different ways. One way would be to multiply the -9 times the -9, and that would give you 81. And when you take the square root of 81, you get 9. But that would not be correct, because we know when we're multiplying a radical by itself, we always get the number that's inside the radical. This should give us -9. Well, let's see if we can come up with a rule for this, because this is very important. If you recall, the square root of -9 is really 3i. That negative becomes the I on the outside. So this is really 3i times 3i, which is 9i squared. Because 3 times 3 is 9, and I times I is I squared. So really what we have to discuss is, and this is, once you'll know this, you really will be able to do anything with these i's. What do you do when you have an I squared? So here we are. Major problem. We know I is the square root of -1. What is I squared? Well, I squared is the square root of -1 times the square root of -1. You are multiplying a square root by itself. That gives you -1. And here is the most important fact, aside from the fact what I squared itself is just -1. And these are the two most important facts you have to remember. You have to remember what I is, because if you got a number with a square root with a negative in it, you're going to have to convert it to an I. And you have to know what I squared is. I squared is a number that doesn't have any square root in it. I is an imaginary number, but I squared is the real number, -1. And whenever I have a situation in which I squared comes up, I don't leave it as I squared. I change it to its equivalent, -1, because it doesn't have a radical anymore. So how does that work? Okay. Suppose I wanted to multiply two complex numbers. Suppose I want, I want to multiply 6 minus 7i times 5 plus 3i. Okay. Guess what I'm going to do? This is already in terms of I. These are really both complex numbers, but they're both binomials, because complex numbers by nature are binomials, because they have two parts, a real part and an imaginary part. And they can't be combined. You can't combine the 6 with the 7i. They're not like terms. But you can use FOIL, just like you've done any binomials. First, 6 times 5 is 30. Oh, outer, 6 times 3i, that's positive 18i. Inner, negative 7i times 5, that's minus 35i. And last, negative 7i times positive 3i is negative 21. And here, be careful, I times I is I squared. And wherever I see an I squared, before I go any further, as soon as I see an I squared, I'm going to replace that I squared by the real number -1, because I squared is -1. It's not we're gonna leave the i's here because they're radicals. But I squared doesn't have any radical in it, it's just -1. So this actually becomes -21 times -1, which is +21. And I add the like terms, the 30 and the 21 is 51, that's the real part. And the 18i minus 35i is -17i. And that's my answer. I can't go any further on this because these are not like terms. But again, you can multiply complex numbers as long as you remember that the I squared, to be careful when you're doing I times I, that you get the I squared and replace it with a -1. Okay, I think you're in the position to add, subtract, multiply, and divide. Well, let's leave division for a minute. Add, subtract, and multiply complex numbers. So I'm now going to put 3 problems on the board, and I'm going to give you a few minutes to try them. And I want to see if you can do these 3 problems. Number 1. Just simplify as much as you can. We have 2i minus 3 parentheses -6 -6i plus 8 minus 23. Remember, I want you to simplify this, combine everything as much as you can. That's question number 1. Question number 2, I'd like you to do this multiplication. 2 minus 3i with a square on the outside of the binomial. And the third question I'd like you to do is 4 minus 7i times 4 plus 7i. Okay, I'm giving you a few minutes to do these 3 problems. As soon as you have an answer for any of them, you could put them on the chat. Okay, see, you got, Shauna has the answer for number 1. So let's do number 1, and then I'll give you some more time to do the others. Let's look at number 1. If you're not finished with the others, just look at number 1. We have 2i minus 3, parentheses, negative 6i plus 8, close parentheses, minus 23. And this is regular algebra. We want to remove the parentheses. So we'll have this 2i, use the distributive law, negative 3 times negative 6i is plus 18i. Negative 3 times positive 8 is negative 24. And minus 23. It's regular algebra. Treat the i's like regular variables, except when it comes to an I squared. Anything, or even an I cubed, because you can break an I cubed into an I squared. And if you can break something down with an I squared, do it. Otherwise, it's just regular, like a regular variable. When we want to write things in a plus bi form, we always want to put the numbers without the I first, which is the negative 24 combined with a negative 23, which is negative 47. And the I second, 2i plus 18i is plus 20i. Now, if you had written 20i minus 47, that's not wrong. But if you're told to put it in what we call a plus bi form, you want to have the plain number without any I first and the number with the I second. That's just the correct format of giving the answer. But you cannot combine these two numbers because this one doesn't have an I and this one does, just like regular like terms. Okay, now I'm going to give you a couple minutes to do this one if you didn't finish it. Okay, see, I was already gotten to the second one and the third one. Wow. Okay, I'm going to give you a couple minutes and then we'll do the second one and the third one. Okay, let's work on the second one. The second one we want to do 2 minus 3i squared. And I'm going to do it two ways because it's a binomial squared. One way is just to use FOIL. Do 2 minus 3i times 2 minus 3i. And use FOIL. This is the normal way that we do the squaring of a binomial. Remember, this is just a regular binomial. First, 2 times 2 is 4. Outer, 2 times negative 3i is negative 6i. Inner, negative 3i times 2, which is again another negative 6i. And finally, negative 3i times negative 3i. So the negative 3 times the negative 3 is positive 9, and the I times I is I squared. That's the one thing you have to remember. When you're multiplying I by itself, I times I is I squared. And as soon as I see this I squared, I replace it with a negative 1. And this is multiplication because this is 9 times I squared. So 9 times negative 1 is negative 9. And I combine the like terms. The 4 and the negative 9 are the real numbers, negative 5. And the negative 6i and the negative 6i combine to negative 12i. And my answer comes out to be negative 5 minus 12i, which is the way you do multiply any two binomials. Again, once you have an I squared, you replace it with negative 1. That's the only thing you have to remember here. I just wanted to show you that I could have done this by that short method that I had told you before. Remember, if you want to square binomial, you square the first term, 2 times 2, and that gives you 4. You square the last term, negative 3i times negative 3i is positive 9i squared. And the middle term comes out to be, you multiply these two together, 2 times negative 3i is negative 6i, and you double it. Negative 6i doubled is negative 12i. And of course, this again is my negative 1. So this again makes this negative 9. And again, I have 4 minus 9, which is negative 5 minus 12i. It's just a bit quicker if you remember the pattern. Either way, of course, you get the exact same answer. You can't combine these any further because this term has I and this one doesn't. Again, we put the number without the I first and the I number second because we want it in. This is the standard way to put what we call complex numbers in the form of A plus BI. Okay, let's now look at the last question. 4 minus 7i times 4 plus 7i. And I recognize these two binomials as conjugate binomials because they are the exact same binomial except one has a plus and one has a minus. And I remember when I'm multiplying conjugate binomials, I have a quick method of just doing first and last because the outer and the inner always cancel out. So first, 4 times 4 is 16. And last, negative 7i times positive 7i is negative 49i squared. And again, I don't have to do the outer and the inner because they're canceling out. This I squared is a negative 1. So this ends up being 16. Well, negative 4 times negative 1 is plus 49. And 16 plus 49 is 65. And the answer to multiplying these two complex number is a number that's just a plain real number. Remember, a real number doesn't have any i's in it. We can multiply two numbers with i's and end up with an answer that has no i's. And this is very important to remember. It always happens when you multiply a when you multiply a complex number by its conjugate, the answer will not be a complex number, it'll be a real number. Now, reals are part of the complex numbers, but it's simpler than a complex number. It doesn't have any i's in it. And this takes us right into the next step of what we want to do. We want to see how we know how to add, subtract, this add, subtract, multiply. Let's look about division. You see, this is really not hard because it really is, except for that one step of changing I squared to negative 1. You're just doing regular algebra, things that we've done before. So there are two types of division that we could have. we could have a division where we would have something like 7 divided by 5i. In other words, we have a single term in the denominator, a monomial. Now remember, the I really is a square root of -1. There is a square root in that denominator. It's not so obvious because it looks just like a letter I, but that I really represents a radical. And when we, just like when we said when we were dealing with radicals, we don't want to leave, even if they say divide, or if they say rationalize the denominator, or simplify, all this means the same thing. You do not want to be left with a radical in the denominator. So how do we get rid of this I, which is the problem? Well, since this is a monomial, I can multiply the top and the bottom by I. Well, multiply by I over I. That's allowed because as long as you multiply the top and the bottom by the exact same number, you haven't changed the value of your fraction. Now, in the denominator, when I multiply, notice I didn't have to use the 5. The 5 was not my problem. The I was my problem. I just worked with the I. I do 5i times I, and that'll give me 5i squared. And when I have an I squared, I'm going to replace it by -1. So I will get in my denominator 5 times -1, which is -5. In my numerator, I do 7 times I, which is just 7i. And remember, you don't usually leave a negative in the denominator, so just move that negative to the front of the fraction. It's -7i over 5. And this is what we want as an answer because our denominator is rationalized. There is no radical, no I in that denominator. Okay. That's what we do when we have an I, just an I in the denominator. But what if we have something like this? Okay, I'm going to erase this. What if I gave you this problem to do? Four over 2 minus 3i. What if you have, and again, it might say divide, it might say find the quotient, it might say simplify. Whatever it is, the problem is that you have a radical, in this case, an I, which is like a radical because it's a square root of -1, in the denominator. And we don't want I's in the denominators, we don't want square roots in the denominators. We've got to somehow get rid of this I from the denominator. That's, even if it says divide, that's what we're aiming for, just to simplify it. So it could just say rationalize the denominator. It could say divide. It could say simplify. What you do is you're going to know what to do with this because it's exactly what we did when we had radicals in our denominators before. We just did an example like that at the beginning of the class. If you have a binomial denominator and you want to get rid of a radical or an I, you simply multiply by its conjugate. In other words, since this says 2 minus 3i, multiply by 2 plus 3i. And of course, whatever you do to the numerator, whatever you do to the denominator, you're going to do the exact same thing to the numerator. You're going to, we decided to multiply by the conjugate of the denominator. We multiply by 2 plus 3i over 2 plus 3i. Really, we're not multiplying by anything but 1, but we're putting it in a position so that we can simplify. Again, like I did with the radicals, I'm going to deal with that denominator first. And remember, since these are conjugates, I just have to multiply the first and the last. 2 times 2 will give me 4. Negative 3i times positive 3i is negative 9i squared. Don't forget that I times I is I squared. And I can replace now this I squared with negative 1. So this will become negative 9 times negative 1 is plus 9. So this is 4 plus 9, which is 13. My denominator, after I multiply it by the conjugate, comes out to be the plain real number 13, no i's in it. What about the numerator? So there are 2 ways I can do the numerator. I could just do what I did before, just write it in the factored form. 4 times 2 plus 3i. But most often, we remove the parentheses, we use a distributive property, and I get 4 times 2 is 8, and 4 times 3i is 12i. And my answer comes out to be 8 plus 12i over 13. Now, if you're told to put it in what we call A plus BI format, in the A plus BI form, they want you to separate it into 2 parts. One that's just a real number and one that's just a I number, an imaginary number. They don't want it all clumped together. So what they would like you to do in that case is to separate it and put the 8 over 13 plus the 12i over 13. That is what's called A plus BI form. Instead of putting it all over the same denominator, just write it each one separately. Okay, I'm going to give you one to try right now. Okay, here's one to try. Suppose I gave you 2 plus I over 2 minus I. And the instructions are simplify and write your answers in the A plus BI form. Simplify and write your answers in A plus BI form. Okay, I think we should go ahead and do it together now. And don't forget to look for homework on Delta Math. I'm gonna put some additional homework of this on Delta Math. You have some that's due on Thursday, so there'll be another set that will be due on Thursday. We will be starting chapter 7 on Thursday. This is the end of chapter 6. And again, I'll tell you when can expect to do your test on chapters 5 and 6. So again, we want to divide, but the big thing is that we have an I in the denominator. We have an irrational denominator. We have a radical. This I is equivalent to a radical. It's a square root of -1. So we have a radical in the denominator. So what we're going to do is we're going to multiply by the conjugate of 2 minus 1, which is going to be 2 plus 1. Remember, we always concentrate on the bottom, on the denominator. Of course, whatever we multiply on the denominator, we multiply the numerator by the exact same thing. So we're multiplying by 2 plus I on top and on bottom. Doing the denominators first, we do 2 times 2, which is 4. And these are conjugates, so I don't have to do outer and inner. I just do negative I times positive I, which is negative I squared. Again, this negative I squared is a -1. So this becomes -1, which is plus 1. And 4 plus 1 gives me that the denominator here is going to turn out to be 5. No radicals, rationalized. But we have to multiply the numerators now together. And these are 2 binomials. Now, it is 2 plus I squared, so you could do it the square method, or you could just do it the FOIL method. 2 times 2 is 4. Outer, I have to do this, and these are not conjugates. I have to do the whole FOIL. 2 times I is 2I. Inner, I times 2, which is another 2I. And last, I times I, which is I squared. And again, as soon as I see that I squared, I put a -1 in place of it. So combining the like terms, I have a 4 plus a -1. Remember, this is not we have a plus a -1. So we're adding 4 and -1, which is giving me +3. And we're adding 2I and 2I, that's giving us 4I. And this is all over 5. But remember, I told you, they asked it for A plus BI form, which means we have to separate it and write it as 3 over 5 plus 4I over 5. That's what's called A plus BI form. This is a correct answer, but if it asks for A plus BI form, you should separate it like this. Okay, excellent. That's excellent. Okay, I think we're going to stop right here. And I will see you Thursday morning. Have a good day, everybody.
Have a good day.
Thanks.
Have a good day.
Thank you. Have a good day.
Bye-bye.
Have a good day.